In a previous lesson, we looked at how to send a process to the background and then back to the foreground. In today's lesson, we'll take a look at how to handle signals, and namely how to prevent the process to be sent to the background at all. How can we actually do that? First, we have this program, right? Like we had in the previous lesson, it's the same one. We just have an X, we print out a prompt, we read it, and then we print a result. So again, if you want to refresh your memory, I can just type in 12 here and just gonna get result 12 times 5 equals 60. So I guess that's obvious. Now, how can we make it so that whenever I do something like this, whenever I launched it from the terminal, whenever I launch it here and say Control Z, it doesn't say has stopped and doesn't do anything, or does whatever I want it to. Because remember, when hitting Control Z, it actually sends a signal to our process, and we want to handle that signal differently. How can we change the way we're treating signals? First, let's include signal.h. That's where most of the signal-related functions and structures are. So the first step is to instantiate here a struct called SIGAction, and we're gonna just name it SA for short. And inside this SIGAction, we can tell it how to handle the signals. So first, what we want is to set up the function that is going to be called whenever we receive a certain signal. So I'm gonna say here sa.sa_handler, and this guy is going to be a pointer to a function. So we're gonna give it a reference to our, well, not yet created handle, let's say sig_tstp. And of course this doesn't exist yet, so we're gonna also create it, and the signature is very simple. You have void, it doesn't return anything. We have the name, and then it takes in the signal that it receives, that we actually handle. That's all this does. And suppose what I want to do here is, well, here we are handling that sig_tstp signal that we should be receiving to actually stop the process. But if we are changing the way we handle it, we are actually no longer stopping the process. So let's print something like stopped not allowed. Why not? And the \n here. And next up is we have to hook this SIGAction to the proper signal, because we didn't specify here in any way the signal. So that's where you have to call the SIGAction function. So SIGAction, it's a function that takes in the signal. So here we give it sig_tstp. Then it is the SIGAction struct that we have created up here. It wants a reference to it because it does set certain stuff in it. So we want to give it a reference to that SA. And then the next one is, if we had another SIGAction set beforehand, it would save it inside the third parameter, so that you would have the old SIGAction, which is kind of neat because that provides you a way to restore the handler if you need to. But in our case, we don't want to, we don't care about it, so we just set it to null. And one last thing, and this doesn't really have to do with all the signal handlers, it just has to do with this one specifically. I want to set inside this SIGAction struct sa dot, and there are a few more options that you can set in here. What I want is to set the sa flags parameter to say equals sa_restart. And that is just because we're using the combination of sig_tstp right here and scanf. Okay, and because they are doing something very strange behind the scenes, it doesn't work well if we don't provide this flag. All right, now what we can do is to try to run this. So again, I'm going to run it from the terminal. I don't want to run it from the VS Code because mine is set up to run GDB, and that's the debugger. I don't care about it right now. So I'm just going to build, and in here I'm just going to run main, right? And I'm going to get input number. If I type in here 12, for sure I'm going to get a proper result. Nice. But what if I run main and then hit Ctrl Z, basically sending this sig_tstp signal to our process? What if I do that? Well, you will notice that it says stop not allowed. In fact, it actually executed our function over here. And if I hit it multiple times, you'll notice that it keeps doing this. So we cannot send this process to the background anymore because we have handled this this signal in our own way by just printing that message on the screen. That's all. Now, well, we cannot send it to the background, so we might as well just execute it, say 12, and then it's gonna finish its execution. And that's really all there is to it. If you want to handle signals in your own way, basically, as you've seen here, we've customized the way this signal works by not actually stopping, but just printing something on the screen. You can do that in C, and it is very nice, I think, using a struct like this. And there's a lot of configurations you can do with this sig action, and then, of course, you can get the previous sig action that was set inside this third parameter. Now, before I finish, I want to take a look at another function. It's very similar to this. This is sig action. There's another function called signal. And this is probably more likely that you have learned about by your teacher at school or something like that. So this function is signal, and all it does, it takes in a signal, so our sig tstp, and then the handler, so our handle sig tstp, and that's it. Right? We don't have to create any structs. And if we try to launch this, so if I build it first and launch it, so say main, then if I hit Ctrl Z, it does exactly the same thing. Now you'd say, why would I not present this function to you and instead show you the longer way of doing it? That is because of the manual page. So here's the manual page for signal, for the signal function, right? And in here, the first line in the description says, the behavior of signal varies across Unix versions and has also varied historically across different versions of Linux. Avoid its use. Use sig action instead. So for portability reasons, basically for having your code run on any version of Unix, you should actually use sig action instead of this signal function. And in my mind, it's not too much of a hassle to actually do this, and it is in fact more convenient because, well, if you want to restore the previous functionality of the signals handlers, it's going to be much easier with this function because it takes in this third parameter, which is nice. Now let's actually play around with this. We have disallowed the process to actually be stopped. Let's allow it to be stopped, right? So let's comment this out. Let's not bind to any handlers. And of course, if I build it and launch it again with main, and I say Ctrl Z, it's going to stop. And if I say FG, it's going to appear here. Now, what if I want, when I say FG, when I bring it back from the background to the foreground to execute and to print out something, what if I want that prompt again, right? Because that prompt is gone. As you can see, it's actually been replaced here and it's no longer here. And I would like to know what it's asking me for. I don't know, it's a number, it's a string, it's what? In fact, you can actually do that with signal handlers. So we can actually change this. So instead of doing this print with stop not allowed for sig tstp, we can set this. So let's make another function, say sig cont. So you can handle sig cont because that is what is called when you use the fg command. And instead of printing this, let's print out that input number sentence. So the same one that we have down here. Okay, and mind you don't really need to have the same exact name as your signals that you're handling. So this is just my convention. You can use whatever names you want. I just like to have them this way because it's easier to know. You're usually going to have one function per signal. And here I have to change this to sig cont, right? So the same, so different handler. And I want this to instead be sig tstp, I want this to be sig cont. And one thing I missed is, well, just to make sure the line is printed on the screen, I'm gonna actually flash the standard output. So it does print this input number right when we execute this number, it doesn't wait for a backslash n or something strange like that. Now, let's try to run this. So let's first build it. So Ctrl+Shift+B, and if I try to run this now, we get input number. Nice. If I say 12, of course it's gonna work. But if I run this and then put it in the background, it's gonna say main has stopped. But when I bring it back, so I say FG, you'd see this prompt again, this input number, and this input number comes from these two lines. Okay, so this is, I think, very nice. And now I know what I need to print. This is nice. I can say, let's say 20, and voila, we get the result, and the program continued its execution. Now you might notice a difference here. With seekCont, well, with seekTSTP, when we changed the handler, it did no longer stop, right? But with this guy, it continued its execution. Why is that? Well, that's just because seekCont is sort of special in the sense that while you can block it, you can handle it differently, it's still going to continue the execution of the process. So it's still going to do the same thing as before, except it's going to do some extra stuff that we added here. And you'll see that for certain signals it's going to do that. For other signals, you're actually not allowed to handle them yourself, and yeah, that's just how things are in Linux. So I hope you got something out of this video. If you do have any questions, please leave them down in the comments below or on our Discord server. Thank you so much for watching. Take care.